Okay, so today I will talk about the GAN dissection paper. So I think that everybody knows what is like a GAN. Just very quickly, a quick reminder. So GAN is a generative model. So the idea is like to from a random distribution to be able like to generate a distribution close to a specific data set. So like for images, it can be like image of faces if you train it on a data set of faces. So the way it works is you train jointly like a generator, which is like suppose like to map this random distribution of like with a low dimensionality to a dimensionality comparable to your image, and then on top of that you have a discriminator, and the responsibility of the discriminator is like to be able like to discriminate images coming from your real data set and images coming from your generated data set. So they are like, yeah, so they are, as I said, they are trained together, and basically when you are around the equilibrium, what is minimized is like the Jensen-Shannon divergence, which is like kind of a metric between like your the distribution of your data, your image data, and of your random data. So that's the idea. And at the beginning, like GAN was generating not very good images, or not high resolution, and on very simple things like faces or the digits, but it has been improved a lot, and today to generate images is like the common use technique, and it generates much more crispy images, for example, than a variational autoencoder. So that's the idea of the GAN. And what the authors are doing, and they want to understand how the GAN work. So which means that how the objects of a particular scene are created, how is encoded the relationship between objects in a scene, and so on. And so what they claim is that it is like the first work to visualize GAN, and because before, like neural network visualization is like I would say a field where people are still working on it. So maybe you have already seen some like notebook where they want to for like standard neural network doing classification to I would created the image which maximize like a specific output. So there's like a Keras-V. If you have not, there's a Keras-V package where you can like see, for example, here is like one image which maximize bird species outputs, and here same thing for neural network visualization. So what is the part of the input image which is most responsible of the specific output for classification. But so that said, that there was like nothing specific done at the GAN level to visualize how I would say the intermediate layers. Some work has already been done to build like interpretable to understand the dimension of the latent vectors. So you can look, for example, at the InfoGAN paper, and what they are trying to do is like to understand the different, or I would say a subset of the dimensionality of your random inputs, and they apply it to faces or to digits, And so they are able to see that, for example, one dimension is responsible of the orientation, the otherwise of the thickness or whatever, but nothing really has been done for the intermediate layer. So that's what we will talk to today. Yeah, so basically I will start with like this small drawing. So this way we'll share all the same like vocabulary. So so here, as we say, when we train a GAN, there's like a generator and the discriminator. Here, like during this paper, we'll focus only on the generator. So how we produce a real image from low dimensionality random vector. But it's done with like a convolutional neural network. So you have like a sequence of layers, like for classification. And so here we will call the intermediate layer R, which is the intermediate layer. And so in this so here sometimes in the papers they call it feature map, so which is like not the usual way to do it, but anyway. And then in this layer you have like what we call usually like several like channel, and in their case they are calling it like unit, and the filter is a unit generator. So the filter is responsible of creating like this output, this unit. And in their work, first, what they would like to see is there is some like correlation between activation of unit at specific position and the appearance or the existence of an object at this specific position in the output image. So we will call like the position P. Here I draw some rectangle, but it just can be like a binary mask with one. Which, so that's it. So basically to be able like to identify some correlation between unit activation and object of a specific class is what they call like dissection, and they start with that. So so then what we can do is to understand the way they do it. The way they do it simply, so they take one layer, so of the generative model, of the generative coordinate, and they generate like a bunch of images, and then they use a segmentation tool to know the presence and or the absence of an object of a specific class and the position in the image generated. And then what they are trying to find is if there are some units for which the activation at this specific position is like correlated to the presence of the object. So to be able to map the position between the unit, the position in the unit and the position in the final image, they are using upsampling because as you can see, so typically how the convolutional GAN is working is like it just increases the resolution of the feature map until they reach the final image. So so to identify the units which are like more responsible of the creation of the object the creation of the object, what they are doing is so they generate a bunch. Sorry, do you have like, is somebody talking? Do you have like any question? Hello?
No, Antoine, no one said anything. Please go on.
No question, okay. So they are like, so yeah, let me go back. So yeah, typically is there like units which are like responsible of the presence of the object at this specific position, and if there's units, which one? Typically, which one, and how do we measure the responsibility of the unit in like creating this object at this position? So, so for that, they are creating like they are using this IUU metric. So they are generating a bunch of images with this specific class of object. Then they are using the segmentation tool to know where the object is, and then what they are and then they are computing that the the activation is defined relative to a specific threshold. We'll talk about it later. So once this threshold has been found, they consider a unit to be at a specific position to be activated if the number is above the threshold, and they are typically like computing the intersection over union.
Intersection
over union, yeah. So any question, or I continue with like how we find the threshold? That's okay. Well, let's continue. So to find this threshold is computed like on a validation set, and they are like maximizing what they call the quantitative information. Typically, it's the ratio of the mutual information between like these two variables, which is like the binary mask in the output image, and the binary mask of the activation of the unit. So this is, and so the ratio is the mutual information divided by the joint entropy. And if you look at this small drawing, like it's kind of makes sense, because if they were only working on the mutual information, as when they move the threshold, the entropy of the X variable, which is the binary mass of the activation, will also change. So to have something kind of independent of that, they are using this threshold. So if you look at the drawing, the mutual information is the intersection between like the two circles, and the joint entropy is the union. So so that's what they are doing, and from that, so at the end of this process, they are able to find a class which are correlated with like the activation of the set of units, and they find also the set of units, and they are able to rank it and to check if how does it work. So to check the results, so you can, so if I find like the paper, so you can find some results of the dissection, page 4. So image on the top. So they have this for like tables and for like sofa. So so that's the results of the dissection. So which class of subject can be explained with activation of units. So sorry, I need to write a bit. So so then called like the second phase is called intervention. So what they say is they don't think that the presence or like the absence of the object will be like only dependent on one specific on the activation of one specific unit, but more like a combination of like this unit activation at a specific position. And to check that, they process like and so what they want to do is okay, so suppose that we reset the activation of a set of units to zero, does the object like disappear? Or if we set at a certain level the activation of this group of units at a specific position, does the object appear or not? And what is the optimal set of units to explain like the presence, the addition or the removal of this object at this specific position? So, so for that, well, they could test like typically all the possibility. It's kind of a set, and for all size of the sets. So they do it in a more clever way. So basically, they are like they are using a multiplicative factor of dimensionality like equal like to the number of total number of units, and they decide to so this multiplicative threshold is like between like 0 and 1, and they are like optimizing it using a stochastic gradient descent. So we can look at the expression of here of their objective, and the name of the objective is, they call it ACE, and I don't remember what average causal effect. So so typically, what is this ACE? Well, is the expectation over all the image generated and all the position of the difference between the binary mask the binary mask of the object you get if you reset this the set of unit, or if you activate it. And as we said, basically in your case, it's not totally reset or activation. They are using a multiplicative coefficient. So say that well, basically they are like learning this coefficient with a stochastic gradient descent and with some kind of regularization. So it's kind of strange. I found a bit strange that they were using like L2 regularization as they want to do some like selection of the units. I would have used L1, but they don't say why they are using L2. So so maybe I can do a pause now before like talking about the result, the interpretation, and so on. If you have like any question.
Hey, Antoine, I have a really stupid question, but the segmentation tool,
yes.
Did they mention what that is, or is it
just... Yes, yeah. They say they...
Antoine?
Antoine, you just muted yourself.
Okay, there you go.
He's frozen. It's not just muted.
Oh, there we go. Yeah, we can hear you again. Or no, that's not it.
No, that's me. That's me talking. Shut up.
Your accents are so similar. I can't tell.
Do I have a French accent now?
Antoine, you must have muted yourself. Click on your own video and you'll see like a menu pop up.
Yeah. It doesn't show muted on his side, actually.
If you click your own name, you should see the menu come up.
Is there a way you can control him, Ashok? Control his mic?
I'm not logged in. Let me try that. I can give that a shot. I think it's on his end. That's why the Mac was prompting him for a password. Antoine, you may need to log back in actually to Zoom. Okay, I think he's trying to log back in.
He's back, and his mic is not muted this time.
Do you hear me?
Yeah, we can hear you.
Yes.
Okay, so my Zoom crashed. I don't know why. So I don't. Okay. So Arshak, you were saying you are talking about this segmentation tool. So it's at the beginning, as you, I was thinking that they were using like manual intervention, but in the results part, page 6, so they mentioned they are to segment the generative images. We use a recent model trained on the ADE 20K scene dataset, and they point also to the paper if we want like further information. And basically, the model can segment the input image in 336 object classes, 29 parts of large objects, and 25 materials. So that's the way they get their like ground truth for segmentation.
Got it. Okay.
Does somebody has some other question about the methodology before we talk about the results? So yeah, I didn't talk about it, but I was thinking how does it work, like this stochastic gradient descent? And so basically, if you go to the supplementary material, they give you like some trick about how to sample like the position of the object and the activation of not of these classes at this position, to avoid like to have like a too small gradient. So it's, I think generally it's worth like to look at the supplementary material for this paper, but here like typically they are doing some trick if we want to reproduce it. So so basically that's the big idea. At the end of the intervention, they know that a specific class can be like activated or deactivated by a specific set of units. Let's say it's on.
Oh no. Antoine, you're muted again.
Or I think it crashed again for him.
Hey, did you guys find any statistics on like how long this thing was trained or anything about the computational aspects of this? Because they started out with a pre-trained GAN for Elson, right? Like how long was that GAN trained for?
Do you hear me?
Yeah, we can hear you now.
Okay, I moved to another computer. Okay. So yeah, Arshak, you were talking.
Yeah, just trying to stall a little bit. Just curious, did you find anything in the paper about the computational aspects? Because I think they started with a pre-trained Elson GAN, right? Like, how long does that take to train? I guess what I'm trying to figure out, like, could this become a general purpose, tool? Obviously, like the segmentation is already domain specific, right? Like it only knows certain classes. And then, how bad is it computationally?
Yeah, so so they're very often they are like talking about like pre-trained model. So so for they are using like pre-trained model for the GAN, and so typically I'm not sure they are fine-tuning. So if you look at, I don't remember the name of it. Let me find the page.
Elson is just massive, right? Like it's, I forget, it's like 10 million images or something like that.
Yes, so exactly. But I think, like to generate like high quality images, high resolution, you need a lot of them. So it's trained on Elson, but they were using like pre-trained models. But the one from NVIDIA, I know. So if somebody finds a page, at some point they are like they are comparing. Yes, so they are using like the progressive GAN.
Oh, the NVIDIA one?
Yeah, the NVIDIA one, the Keras guy one, yeah.
Yeah, I think that was trained for a long time.
Yeah, I think so. So okay, we studied 3 variants of progressive GAN trained on Elson datasets. So so that's, yeah. So typically, I think they, I'm not sure they retrain it, but they took this pre-trained model, I think. And several variants of it, because typically in the results they want to correlate so their metrics of unit, I would say that classes discovery, and some metric used for evaluating the quality of the GAN. One is called like SWD. I didn't check what exactly it was. It's for slide search time distance. It has been introduced recently. And typically, basically what they say is there was some improvement in the generation of images using GAN. So there are the standard progressive GAN. After that, there was a batch standard deviation. So and then a technique called pixel-wise normalization. And this improvement has been measured visually, but also using this metric called slide search time distance. And in the meantime, they say, okay, if we look at the number of object unit detected or part unit detected with our methodology, this increase with the improvement of the quality of the SWD metric of the generation of images. So yeah, they work with like several variants of progressive GAN during their work.
Did this paper remind you of like the OpenAI sentiment neuron a little bit? Like, I think they used the same similar. I mean, this is much more sophisticated in terms of what they had to do, but this notion of, taking some embedding, running L1 or L2 regularization to find the units that, are getting activated on.
Yeah, I think, I should go back. I don't remember. To be honest, I don't remember exactly this paper. So at the beginning, I was just thinking when I read the abstract, okay, they want to understand how the GAN is working and what the units, different units are doing, and they say, okay, it's not the first time people are doing it because there was like info GAN and there's some other, but here it's, I would say for me, the first paper, at least I remember that worked at intermediate layers, but I should have looked at this sentiment analysis of this OpenAI paper. I don't remember.
Yeah, it's in the language limit. What was the one we tried to implement at Sentient that had a like a Facebook paper?
Yeah, it's Fairsec, or I don't remember. I will share it on the channel. Yeah. So the idea was like to be able like to learn latent representation and activate them or deactivate them, and try to be able like to add, for example, glasses to faces.
Exactly.
Or to move from a man to a woman. So yeah, but I will share it on the channel. I forgot the name of the specific network. But I would say it's the main difference between like these two papers for me. It's once the Facebook one, the work is done during training. So basically, they are like trying to find interpretable latent dimension and then to play with it to generate other images. Here is you already have your train GAN, and you want to understand how units are working together to generate objects. Does it make sense?
Yeah. I think this like IOU thing is a little bit kind of novel, you know, like it's a more sophisticated approach to looking at the activations than I've seen before.
Yeah. Yeah, it's. I think yeah, it's kind of like a. It's a good idea, and it's. I was wondering when I was reading the paper, but how did they make this work? Because well, you can have the idea, but after that, make it work can be like kind of complicated. And so yeah, so typically they use some kind of trick with like they found this good threshold approach, I think, and also the way they train the network by sampling a specific position. If you look at the supplementary material, I think it's kind of crucial if you want to make it work. So let me find a Facebook paper. I will share it on the channel. All right. Well, I will. No, I don't find it. So I will find it. I will share it later because I don't remember the name. So yeah. So if we go back to the paper and talk about so the results they get. So yeah. So as we were talking, so typically. This is kind of useful. So basically the detection of different units in the scene is kind of like correlated with a standard metric to measure the quality of the image generated by a GAN. What they find also is, so typically if you look at the GAN, so from the random latent vector and the generative image. So at the beginning, everything is kind of entangled, and typically the unit activated at the bottom layer are not very meaningful. And then you have like more like big concept like scene. Then you have like objects, and at the end it's more like the material. So it's like for like bigger concept to very small details, which to generate image, which kind of like makes sense. We are also Yeah, so how to improve, well, basically like the GAN still have some artifacts, so something that we don't really understand why it appears in the scene. And typically it's like kind of like a common problem of the GAN and of stability of the GAN, and typically it's kind of like due to the metric you are using. So you can add some mode and miss some mode, and you don't penalize too much the training if you add something totally irrelevant and it's due to the Jensen-Shannon metric. And so to know how they can like improve that, so first they ask people like to label strange artifacts in an image, and from this collection of strange artifacts in a big collection of images, they were able to detect like the 20 units responsible of the generation of this artifact. And when they reset this unit, the artifact disappear and the image generating is much more better. And much more better, like to measure, you know, why it's better. So there are two approaches. There's one called like, there's one using like mechanical Turk and people like scoring the quality of the images. Also, they are using FID for fresh inception distance. So it's a metric which has been introduced, and so typically it looks at like the image goes through an inception and network, and they take the output of a specific layer, and then they compute the correlation between like a real data set and a generated data set from this output of this inception layer. And and they compute this score, and lower is the score, better is the image, basically. And typically, so they can show that if they ablate, do the ablation of this artifact using their techniques, they improve this metric. And also they started to work on remove like the human intervention to be able to detect artifacts. And so for that, typically they are using FID. So and so if I remember correctly, to do that, so basically they deactivate like all the different units, and they compute like the FID and with like real images. And so using that, they are able to detect what are the problematic units and able to deactivate them in the future to generate like more real images. I think there's still some like open question in their work. So typically, so for certain scene, even if you like try to reset, for example, all the chairs in a conference room, it does not work. So some chairs are still appearing. So and so that means that you cannot just act on one object and expect that you will, as the goal is to generate real images, you will generate an images with this scene without this object, as like during the training, all the conference room has been seen with chairs. So maybe what they could do, because I don't think they have done it, is so first they reset, so they generate an image with less chair, but they're still chairs. And so maybe what they could try to do is like to redo the experiment on the next layer, so a layer closer to the final image, after resetting the unit to see, because the next layer typically like activation would have changed, and maybe they should be able like to reiterate this process until the final image, maybe. Otherwise, the other thing also they notice is they cannot add objects everywhere in the image. So typically, for example, if they activate like units responsible for door generation, but at a position where there's a sky, typically the door does not appear in the final image. So there's so in the next layer, certainly there's some check. I don't know exactly how it works, but which is like responsible of removing this this unit, because like remember when we find this unit, it's based on average, so average position. So so if you add it in a position which it does not make sense, but typically there's something later in the network which is able to discard it. So I think we talked about approximately everything. So my main question now is, well, first, do you have questions? But the thing is, how can we use that in the platform? So maybe Arshak, you had something in mind, like before, like suggesting this paper.
Yeah.